Okay, class, welcome back. It's been a minute, but let's talk about adding and subtracting monomials. This was getting started into the session on adding and subtracting polynomials. Okay, we have the problem 2s squared plus 3x squared plus s. Now, we've already stated that when we add polynomials, one thing we're doing is just simply combining like terms. So we have three little steps that we want to briefly run through. The first one says we need to identify the like terms. So here I have s squared and s as my like terms. Then it says to rearrange these terms so that the like terms are together. So actually, my s squared and s squared are together, and then now I just simply have to combine them. So to do so, I just simply add the coefficient here. That'll be 2 plus 3. That's going to give me 5s squared plus s. Okay, just that simple. Okay, so we cannot combine s and s squared, so actually that would be our final answer. So let's take a look at problem 2. Same thing, we want to identify our like terms. I have z to the 4th power, and I also have the constant 8 and 2. So two sets of like terms. So let's rearrange them so we can have them right together. So I'm going to use what's called commutative property and switch places with -8 and 16 z to the 4th. Okay, so doing that, I will have 4 z to the 4th, okay, and switching places, so plus 16 z to the 4th. I'm going to just go ahead and group these, and now that's going to give me a plus. What else do I have here? I have a -8 plus 2. Okay, so as I combine my 16 and 4, that's going to give me 20, and that's going to be z. So I'm looking at 20z to the 4th power. Okay, that's adding 4 plus 16, and that's going to be minus 6. We have a -8, and we're going to add to it a +2. So we know our integer definition say you take the absolute value of the larger, subtract from it the absolute value of the smaller, and use the sign of the larger. So that'll give me 20z to the 4th minus 6. Pretty simple. Let's take a look at a couple more prior to actually looking at the concept for actual polynomials. We're just warming up here. So let's take a look at problem 3, and let's use 2x to the 8th power plus 7y to the 8th power minus x to the 8th power minus y to the 8th power. Oh, well, let's see what we have. We have like terms of 8 to the x and y to the x. So we need to, let's group, and here we will use commutative property and switch -x to the 8 with 7y to the 8. So that's going to give me 2x to the 8 minus x to the 8 plus 7y to the 8 minus y to the 8. And Combining my like terms here, I have a plus 2 and a negative 1. That's going to give me x to the 8. And here I have a plus 7 and a negative 1. That's going to give me plus 6y to the 8. Okay, outstanding. One more problem, and we'll use this as problem 4. Let's take a look at 9b to the third c squared plus 5b to the third c squared minus 13b to the third c squared. Well, b to the third c squared. Those are my like terms. So no need to rearrange. Let's just go ahead and combine them. So I have 9 plus 5, which is 14. So let's just go ahead and write this. So I have 14b to the third c squared, and that's going to be minus 13b to the third c squared. Well, 14 plus a negative 13 is going to give me b to the third c squared. Now we have to make sure that we understand that when there's not a coefficient in front of the variable, then that coefficient is 1. But anyway, it's not that difficult to begin with. So I'll see you next time as we talk about the different methods for adding and subtracting polynomials. See you then.